This is the Year 8 separation techniques, reverse the classroom. So before you do the unit, what you're going to do is by watching this video, you're going to have a pretty good idea about what is then going to come up in the unit, so you've got an idea about the actual practicals involved. So what I'm going to do is I'm going to go through the main separation techniques. We've got filtration and crystallization, distillation, chromatography. Okay. Just before we start, just have kind of a few keywords that also need to be used. Now, all these keywords here, right, they're all a bit of a pain because they all kind of sound very similar. Now, if you think about a cup of coffee, now this isn't the perfect example, but it does kind of illustrate it a little bit. The solute is the stuff that is actually being dissolved in there, all right? So we've got the coffee, right, and we've got the sugar. Okay, so a nice black coffee. The solvent is the water that is going in there that dissolves the two substances. And then the final thing at the end, that there is my coffee, which is then a mixture of the solvent and the solute. Now these are then 5 separation techniques I'm going to go through. I'm not necessarily going to go through this order, right? But distillation, evaporation, crystallization, chromatography, and filtration. Right, so the first one, filtration. Now the whole point in filtration, and this is any answer that you ever need to give, it is to separate insoluble solids from your solution, right? So it's, it's insoluble, which means it doesn't dissolve in water. Now a good example could be sand, right? If you've got sand in a mixture, and what you try and do is you try and, you want to get it out of the mixture, what you do is you filter it. Right, if you've got grass, if you've got dirty water, one of the main ways of actually getting rid of stuff out of something is to filter it. Now the example I've got on here is copper oxide. Now the reason why I've got this is because it's an insoluble solid and it's also part of a required practical. So it gives you a bit of an idea. And what it is, it's a black kind of solid substance. What you do is you mix it with sulfuric acid, and eventually what you do is you make copper sulfate. Now that's kind of not the point of this itself. The point is filtration. Filtration is where you use a filter funnel, which is just like a plastic funnel. You then put a piece of filter paper into your funnel, and then you pour your liquid in that's got the insoluble solids in. Now you've got to be careful with this one. Quite often what people do is, oh, I'm bored of this, let's make it go through faster. So they get a little stick and they kind of wiggle it around inside there, just makes a hole in it, and then you just have to start it again. So if this at the bottom here isn't really, really nice and clean, you need to do it again because there's a problem. Number 2, evaporation. Right, now this kind of leads on from the practical before, because in that practical before, what we made is we made a copper sulfate solution, right, which is a lovely kind of blue solution. Now, what evaporation is, evaporation removes the solvent. And if you remember from that first one, the solvent is the liquid, right? So if I've got my cup of coffee, right, I've got my cup of coffee, and what I want to do is remove the solvent. What I'll be doing is removing the water, leaving behind the solute, which is then kind of the substance that we got, the coffee and the sugar, the hard bits, the solid bits. And the way you do that is you have a beaker of boiling water. All right, so that water there is boiling, and on top of it, what you've then got is you've got an evaporating basin, and in that evaporating basin is then your solution. Now the reason why you do it this way is if you just put the evaporating basin straight on the Bunsen burner, it will boil very, very quickly, right, and it will be kind of a little bit uncontrollable. So what you do is you put a beaker of water on, and that beaker of water then provides the heat to evaporate the liquid off. Right, it's just kind of a better, more efficient way, well not necessarily efficient, but a better kind of more controllable way of doing these things. It's kind of a bit like melting sugar at home, not sugar, chocolate at home, right? You don't put chocolate straight in the saucepan because what happens is it burns. So what you do is you put it over a bowl of water and you melt it that way. Next one, crystallization. Now this one works pretty much exactly the same as evaporation, except for when you get to this point here, what you do is you heat it up quickly, get it to a good temperature, and then you put the hot liquid into a crystallization dish, and then you leave it And over time, then what happens is you get your crystals forming. Where on the evaporation one, the one we just did, right, what happens is you don't get big crystals because everything's done very quickly. Distillation. Right, so what I've got here is got distillation. Now this is a procedure in which two liquids with different boiling points are separated. Now, I don't like this example on here, salt water, right, because really what you've got is you've got salt and water. So you're not really separating out two liquids. I like, so I'll do ethanol and water. Okay, in a way it's like a bottle of wine, a bottle of vodka. What you've got is you've got your ethanol, which is your alcohol, and then you've got water. Now the most important part of this is the fact that ethanol boils at about 80 degrees C and water boils at about 100 degrees C. And so what you then do is you then heat them both up, and at 80 degrees C what happens is it starts to boil. And when it boils, the fumes go up inside here and into this here, which is called a condenser. Sometimes it's called a Liebig, that's L-E-I-B-I-G, condenser. And what you have, this kind of darker bit around the outside, is cold water. And so it's like a jacket of cold water. The water goes in at the bottom of the condenser to make sure it gets filled up, and then that cools down the gases. When it cools down the gases, out of this end, you then get pure ethanol. Once all the ethanol has boiled off, it then stops boiling. What it does, it stops boiling. And then it goes up 81, 82, 83, all the way up to 100, and then the water then starts to boil. But you don't want the water boiling, or all of a sudden, then you're going to get water in your distillate at the end. Okay, so that distillate there, right, we'll call that ethanol. Just a better way of doing it. Chromatography. This is then used to separate mixtures of chemicals by their solubility. Often it's done with ink, or it can be done with food colourings. Okay, so what I've got here is I've got a piece of paper. I'll do the piece of paper in black, so that's the piece of paper. I won't do all the way around. It's in a beaker, which is this here. It's got a wooden splint going across the top, and the piece of paper then dangles down, and it dangles down into water solvent. But what you do is you have different coloured dots of food colourings or ink on your piece of paper. And where you put those dots, you usually do it 2 centimetres from the bottom of the piece of paper. And you draw a line across using pencil, right? Because if it was done with ink, the ink would then travel up the piece of paper as well. So what they do is they do it with pencil. Then what we have is we have here, we have our unknown, right? It's an unknown colour. When you put it into the water, what happens is all the different colours travel up. Okay, or should have been in red, they will travel up. And eventually what they'll do is they'll get to a certain point and the solvent front stops about 1 centimetre from the top. That's where you stop it, 1 centimetre from the top. You can then see where the different colours have gone up. And if in this unknown one it kind of stops there, and you'll be able to see because obviously it won't be black, if it kind of stops there and it kind of stops there, you can then work out what colours are in the unknown one. Now this is then another method, right, and it's kind of adding a number of things together. It's separating out water, sand and salt. You've got your insoluble solid, you filter it, which is this one. No, it's this one where we're filtering it. Right. Number 1 and number 2 is collect your equipment. Number 2 is then mix it up with water to dissolve the salt. Number 3 is then filter, and what you do is then you filter out the sand. And step number 4 is where you are getting rid of your salt in an evaporating dish. Now, they are then the 5 main sort of separation techniques. Question number 1 to be written down in your exercise book is list the 5 separation techniques. Which method would you use to separate an insoluble solid? It's one word. Which method separates based on their solubility? Kind of one word. List the 4 steps to separate sand, salt and water. 4 steps. What piece of equipment cools down the vapour in distillation? 1 word. But what you've got to do is you've got to make sure you write out the questions first. Now they are then the separation techniques, right? You need to know the methods and how to actually use the equipment, because those separation techniques will come up in Year 9, Year 10, Year 11, and will be on your end of Year 11 exam.